In this video, we're going to explore calculating trig values using our calculator. So number one here, we have these, we're trying to find the sine of 30, cosine 30, and tangent of 30. We're going to round all of our answers to 3 decimal places. These are not going to be nice, easy fractions like we had in our previous video. So what we're first going to do is identify that this is our 30-degree angle. So that's the one that we really need. I'm going to label my sides based on that, and I'm just going to use quick abbreviations like O, A, and H. This is my opposite, my adjacent, and my hypotenuse. And to find the sine of 30, I want to put the opposite side divided by the hypotenuse, so 8 over 16. And again, because we're rounding that, I'm not going to reduce the fraction, but I'm just going to take 8 divided by 16, which will give me 0.5. The cosine is the adjacent over hypotenuse, so it's going to be 8 times the square root of 3 divided by 16. I don't know what that is very quickly, like I did 8 over 16, so I'm going to use my calculator to go ahead and calculate that value. So we have 8 square root of, helps if I press it right, 8 square root of 3 and divided by 16. And so that's going to give us 0.866. To find the tangent, I'm going to do my opposite side over my adjacent, so 8 divided by 8 root 3. Alright, so I'm going to actually set up a fraction for this one, math, n over d. 8 divided by 8 square root of 3. And so we end up getting 0.577. So in number 3 and 4, it's a similar type of thing, except we don't have all the pieces that we need. So we're going to actually go ahead and get this all set up. In order to find the missing side of the triangle, I'm going to use the Pythagorean theorem. So I'm going to take 4 squared, which is 16, plus 7 squared, which is 49. And together they give me 65. So my hypotenuse, and I'm going to, I don't know, probably anger some math people here, but I'm just going to leave it as the square root of 65, and I'm not even going to bother to attempt to simplify that radical, because I'm not done yet. What I'm trying to find is the sine, the cosine, and the tangent. So if I circle A, 7 is my opposite side, 4 is my adjacent side, and then square root of 65 is our hypotenuse. So the sine of A is going to be 7 divided by the square root of 65, and I'll save the calculation for you to do. Cosine is going to be the adjacent over hypotenuse, so 4 over the square root of 65, and the tangent is the opposite side over adjacent, so 7 divided by 4. So you might have to find the missing side of the triangle before you can actually go ahead and set up your sine, cosine, and tangent ratios. So how do we use a calculator, though? Because we want to be able to find any single value of sine, cosine, or tangent. One of the most important things is we have to be in the correct mode. So I would recommend that you pause the video for just a moment so you can verify that your calculator is in the right mode. And really what you have to do is go to hit mode on the calculator and just verify that yours is in the correct mode. Now that you've verified it, we're going to actually calculate what these values are. So we want to round all of our answers to 3 decimal places. And simply put, if I want to find the sine of 81, I'm just going to press, let me quit out of here first of all. I'm going to go to sine 81. And I'm getting 0.988 when we round to 3 decimal places. I don't know why that moved on me. Hold on. All right, we're back. Sorry about that. So sine of 81 is 0.9, and what did we say, 88? Yes, 988. And we can do this for any of the sides. I'm going to pick one here, tangent of 57, just as kind of a random one. So tangent of 57 gives us this decimal. If we're rounding to 3 decimal places, I'm looking after the decimal point, so 1.5. 398 is going to round this up and round that up. So 1.540. be our tangent of 57 degrees. Okay? So again, really you're typing in the calculator and just making sure you're rounding appropriately. So let's practice solving proportions, because this is going to be an important skill for us, especially when we get to the next part, that we can solve those. To solve a proportion, what we're going to be doing is just cross multiplying. So I'm going to take 2 times 14, and that's supposed to equal 3 times x. So 28 equals 3x. X is 28 divided by 3. We need that little review because you're going to see in the next part, proportions are a nice, easy way to set up some trig problems. So there's two different types of these proportion trig problems. One we're looking for the side that's on the top, and one we're looking for the side on the bottom. And our setup is going to be a little bit different for each, or well, sorry, how we solve is going to be a little bit different, but our setup is going to be exactly the same. I want to treat this as proportions. I think it makes it easier. So on this side, I'm going to write it as set of 25 degrees divided by 1. Now to solve that, I can cross multiply, and I would have x equals 16 sine of 25 degrees. So if I want to know that value, I'm just going to type that exactly in my calculator as I see it. So I'm going to go 16 sine 25. Let me check the rounding here. We're supposed to go to 3 decimal places. So that would be 6.762. Okay. Number 18 is one that looks initially different, but same basic idea. It's just going to be a little bit more challenging to solve. So we want to cross multiply that. I've got x cosine of 73 degrees, and that equals 19. So when I to solve for x, I'm going to have to divide by cosine of 73. And so let's type that in, 19 divided by cosine of 73. So I've got 64.986. All right. So that's how we're going to cross multiply to help solve those types of problems. So if we're looking to solve for the missing side of a triangle, we really got 2 types, or well, 3 types technically. We want to know, first of all, what kind of pieces of information do we have? On this triangle right here, we have 2 angles given to us and 1 side, and a side that's not the hypotenuse. One easy thing for us to find would be to find the missing angle. So if I know that I've got a 90 degree and a 40 degree, my remaining angle will be the one that adds all that up to 180. So it's got to be a 50 degree angle here for angle B. Now I want to find some missing sides. So I got options on what I can do. Let's use that 40 degree angle that we were given and label the side. So this is my opposite side. This is my adjacent side. And this is my hypotenuse. So if I'm trying to solve for either the opposite or hypotenuse, I do have my adjacent side given to me. What's probably best for me to do then is to set up a tangent. And the reason I'm going to set up a tangent is because the tangent is the opposite side over the adjacent. I don't know what the opposite side is. I'm going to call that x. So if I'm solving this, my tangent of 40 degrees equals my opposite side x divided by my adjacent side 6. So x is 6 times the tangent of 40 degrees. So I'm going to find out what that is. I'm going to go to my calculator, and I get 5.0 rounding to the nearest tenth. What I can do next then is find the hypotenuse, and I've got a lot of options on what I can do. I think my best option though is actually going to be use the Pythagorean theorem at this point. So I'm going to take this number, square it, and I'm going to add in 6 squared and take the square root of that. There we go. And I've got 7.8 for my hypotenuse. '21 is a similar type of problem, but the setup's a little bit different because now we have the hypotenuse. So I still want to find this missing angle by subtracting from 180. And if I'm looking at the 53-degree angle, across from it, that's my opposite side. This is my adjacent side, and this is my hypotenuse. The fact that I have hypotenuse, it's actually a good thing for us because now we can use the sine and cosine more readily. So I'm going to start with the sine. The sine of 53, let's call this x, is x over the hypotenuse, which is 15. So we'll type that in, 15 sine of 53. And we get 11.979, rounded to the nearest tenth, would be 12.0. And I can do the same thing for the adjacent side. Let's call it y. Cosine of 53 is y over 15. So y is 15 cosine of 53. .027, we're going to call that nearest tenth, 9.0. So that's part one of this section. We're going to do a little bit more with this in the next video. Essentially what we're going to be doing is kind of working backwards and trying to find out what our angle is if we already know what the ratio is.